Now we'll see how to introduce two stall cycles. Okay, how to see the two stall cycles in the picture. I will explain that, don't worry. Example, when you get that situation is there is no forwarding circuit and load is updating the R1 value. Add wants to use that R1 in the execution stage. Okay, if there is no forwarding circuit, then what happens? You see, fetch, decode, execute, memory, write back. This is about load. Now load is giving us data here, right? So here we have to do at least execution. If you do execution here, that would be fine. We don't get any problem. Sorry, but to get execution here, data is coming from decode stage, right? We can't execute here. We have to decode here. Try to understand. If second instruction, if you decode here, then is there any clash? No. Already I explained that, correct? This write back stage is writing the data in the first half cycle. Decode is reading the registers in the second half. So by that time already data is written, there is no problem. For that we have to fetch here. But unfortunately this kind of postponing is not possible in pipelining, because how do you know that we have to fetch this kind of instructions here? Are we are we so intelligent so that we can predict that the next instruction will have dependency? No, right? That means we can't fetch here. We have to normally fetch the instruction here itself, but later we have to detect it. So that's why how this instruction will be fetched and how we will understand everything we will see. Let me show with one example. Okay, so pictorially this will be the right idea to understand things. Let's take 5 stages. Okay, with this I explain you what is the meaning of introducing two stall cycles, how they will be implemented. This is fetch stage, okay, this is decode, this is execution stage, this is memory stage, write back stage. These are the fixed circuitry. Now only thing is varying is the instructions which are to be executed, correct? So sometimes instruction, first instruction will be fetched, after that the instruction will be decoded in that way, right? Let us understand the details with the clock cycles. In the early morning at the first clock cycle, what is going to happen is I1 will be fetched, correct? So there will not be any problem for you. Let us take this example and let me show the stall cycles. Okay, now in the second clock cycle what happens, everything will be good. I1 will come to decode stage, I1 will come to I2 will come to fetch. Now so we are decoding. Example here at the second clock cycle you are decoding I1. By that time you don't know about I2, so you don't know that whether there is a dependency or not. We can't predict anything, that's why we do normal, as normal. At the third clock cycle, they will be moved, right? I1 with all its control signals and all its essential information, it will come to third stage, right? It will bring all the essential details. So that means it vacates this position, decoding position, so that I2 will be moved here. So new instruction will be fetched. This is the way generally pipelining works. Now you see at the third clock cycle, decoder is decoding I2, executor is executing I1, fetch circuit is fetching the I3, correct? Now after end of the third clock cycle, what is going to happen is there is a circuit. Assume that we have some extra circuit. That circuit will detect that there is a dependency between these two instructions. Already I told you such circuit we can design which will read this destination, which will read that sources, and there will be a circuit. They will take the input R1 and this R2 and this R1. That means first instructions destination, second instructions source identifiers, and the circuit can detect that there is a dependency, and it will understand that the dependency is very big dependency because of load instruction. Such a way we have to plan the circuit, because by reading this, because already we know that the previous instruction is load, right, and the next instruction is add, and the dependency is two stalls. That means because of this dependency, to get the right answer we have to, this second instruction should wait for two stalls. That means two clock cycles, correct? So how that thing will happen I will tell you, because we are in the full flow, right? So for that what we do is the circuit will detect the dependency and it will create two stall cycles. Creating two stall cycles happens like this. How you see? At the fourth clock cycle, nothing will happen to memory. That means, I1 is having its own signals, they will not be disturbed. Okay, we don't disturb them. It is carrying its own signals, because of that it is doing its memory operation perfectly. Now this I2 is bringing its signals to this one. If I2 brings its proper signals with it to buffers, understanding, if I2 brings all its essential details to execution stage, I2 also gets executed, but that should not happen. We have to stop it. That is what stalling. What we do, I2's control signals we disable. So because example, at the third clock cycle, what we do is we realize that there is a dependency. Already at third clock cycle we realized, right? So at the third clock cycle, we just at the fourth clock cycle we send only all the dummy signals, remember, not the right signals. Okay, dummy signals. That is one important thing you should remember. So now I2 comes with all the dummy signals. Let me put a bubble like this. Whenever I circle like this, that means I2 is bringing all the dummy signals, so that there is no effect of execution of it, there is no effect of doing memory, there is no effect of doing write back. Example, simply I will tell you, there is an adder circuit. Okay, now I2 actually should add the things, right? To add the things, this adder should be enabled. Already I told you, correct? What we do is, we don't send the proper control signal with I2. So I2 is not getting the proper signal, so that it will be, I will give one analogy, like, I2 treat like a person. This person wants to open this execution. That means he wants to open adder. He wants to ask adder, my dear adder, please, I am giving you registers, please add them. But this adder will not respond. It asks to show the appropriate password, that is control signal. But what we do is, at the third clock cycle we realize that there is a danger, right? So that's why while sending I2, see, I2 came from here to here, right? I2 brought all the dummy signals, all its passwords are illegal. Okay, they are expired, so that I2 cannot do its work. So finally, how to understand this one is, because of all zero control signals, then I2 will not be executed, right? Now, but forwarding will take place. Now, I3 is supposed to come here, but one more thing we should do. We should not decode I3, correct? Why? Because I2 is not performed so far. That's why in this one, what we do is, still we take the old instruction only. That is one thing extra you should understand. What are we doing? Rather than taking from I3, when there is a stall cycle, at that period, we have to take again I2 only. Such a way, we have to create a circuit. Yes, it is possible. That means again bypassing. Should I take the instruction from fetch stage or existing one? So in that way we can plan it again. The same instruction we can take. Already we have that instruction. We take it again and we decode it again. Try to understand. Now, sir, what about this fetch stage? So this fetch stage can fetch now new instruction. Let's say, think about it. Sir, should I fetch a new instruction? If you fetch new instruction, what is going to happen? You see, I1, dummy I2, real I2, I4. Then where is I3? You missed I3, right? Not to miss I3, what we have to do is, we should not increment program counter at some point of time. What is that point of time? I will show that. Now we'll come back again, okay? So that now you can understand the things clearly. What I'm going to do is, at the first clock cycle, let's say whatever the program counter, let me assume that program counter is 100, okay? Because of that, I1 comes to fetch stage. This is program counter. Now time is 1. Now when time is incremented, when at second clock cycle, because program counter will be incremented whenever fetch is done, so I1 will go to decode stage. That means I1's fetching is done. At that time, did you remember any instruction is fetched in that fetch stage? We also increment program counter. This time again fetch operation is done. Then fetch is going to fetch at 104, which is nothing but I2. Perfect. Now after that, automatically at the third clock cycle, what is going to happen is, I1 will be moved here, I2 will be moved here, I3 will come here. Why? Because at third clock cycle again program counter will be incremented. Because program counter is incremented again, then it will fetch an instruction at 108, which is nothing but I3. In that way, now see, in the first clock cycle, hundreds instruction will be fetched, instruction at 100. At second clock cycle, instruction at 104. At the third clock cycle, instruction at 108. You remember it, okay? Now at 4th clock cycle, what we have to do is important. At 4th clock cycle, by that time you realize that already in the 3rd clock cycle, you realize that this instruction I2 has a problem. We have to stop it. To stop it, what we do in the 4th clock cycle, we send I1 as it is to memory, but we don't send I2 as it is to execution. What we send then? I2 with all the dummy signals. We don't send the original signals. You got my point? Such a way we should have a circuit. So there should be a circuit which will have set of dummy signals, all zeros, and original signals. Original signals are already, coming from decode stage. So this time I2 is moved to execution stage, but not with its original signals, all dummy signals. So that I2 will not have any effect on any register or anything, on arithmetic or anything. So now the question, sir, who will come to decode stage? Obviously, it can come from I3, but I don't want to get I3 because I2 is not done, right? That's why I will repeat I2 here. So for that again you will have extra circuit. That circuit should bring I2 here whenever there is a stall cycle. This is what implementation of stall cycle. How stall cycle is implemented? You should have a very big circuit that will do all this stuff. So that now you understood that I1 is moved properly, I2 is moved properly, correct, but with dummy signals. Now who is coming to decode stage? Again I2. That means previous I2 is there, right? Same instruction we have to bring. Okay. Now that is already in the buffer, we bring it. Now actually it's supposed to be I3, but we did not do that. Now the question is at 4th clock cycle, who should come here? Generally remember one thing. So now initially program counter was 100, then 104, then 108. See, at the 1st clock cycle program counter 100. At 2nd clock cycle program counter is 104. At 3rd clock cycle program counter is 108. At the 4th clock cycle program counter will become 112. But you want to introduce stall cycle, right? Really, if you want to introduce one stall cycle, program counter should not be incremented. That's why what you have to do is actually where program counter is getting incremented at fetch stage, correct? So at that time the fetch stage should not increment program counter. We have to disable the signals of program counter. That's it. Now let me tell you again. 1, 2, 3. Let me quickly do that. 1st clock cycle I1 is here. 2nd clock cycle I2 is here. I1 is here. Sorry. I1 is here. I2 is here. At 3rd clock cycle I1 is here, I2 is here, I3 is here, and you realize that there is a threat. You wanted to introduce 2 clock stall cycles. That's why what we do is after end of the 3rd clock cycle, immediately disable program counter, lock it. Just imagination. We disable program counter so that program counter will not be incremented. So that means at 4th clock cycle, again program counter shows same 108. Because of that, what is going to happen, we'll see. Now let us focus on 4th clock cycle. At 4th clock cycle, obviously I1 happily with its original control signal will come to memory so that it will do this memory operation. But unfortunately I2 is getting only dummy signals. That's why I2 will not have any effect. Though I2 instruction is getting moved here, but dummy, there is no effect on that environment. Now what about this one? Here again we move I2 only, okay, but don't put dummy, bubble here, because here we are really decoding it again. We are not dummily decoding, we are really decoding. Now here fetch is normal, whatever program counter shows you fetch it. So program counter is showing 108, that means it should fetch again I3. Now you see I3 is fetched second time, I2 is moved 2 times, I1 is properly working. Now in the 5th clock cycle, up to now 4 clock cycles are done. In the 5th clock cycle, what do you want to do? Do you want to introduce one more stall? If you want to introduce one more stall, what you do is you continue the same story. This I2 also, see, I will show the movement. Mr. I1, please come safely. Yes. No. Mr. I2, blindly you come here as usual, but your signals are all dummy. You can't do anything to anyone, right? There is no effect of you. Now this place is empty. Now this stage is coming here, right? Then this decoder have 2 options at 5th clock cycle. it can send original instruction with proper assets or proper signals or dummy signals. What do you want? If you want another stall cycle, send I2 with again dummy signals, so that this instruction also will not have any effect. Okay, let us do that, because I want 2 clock cycles, right? 2 stall cycles, 2 stalls. So 2 stalls are introduced like this. We are at the 5th clock cycle, remember it. Okay, that's why I1 is here, I2 is here, one more I2 dummy is here. Now again decode I2 only. Such a way we plan. Whenever there is a stall cycle, this decoder should decode the previous instruction. Now this fetch should fetch previous instruction again, because program counter is again locked, right? So don't release it. Now at 5th clock cycle also, so that will be dummy. So finally what I want to tell you is, we did 1 2 3 perfectly as usual, normal, but 4 5 we did some extra things so that stalls are happened. Okay, now 6th clock cycle you should be serious. Okay, now you do normal. Normal means don't unnecessarily disable anything, blindly execute the instructions. See what happens. So at 6th clock cycle he will fall down like this. That means I1 says yes, I got executed. Now at 6th clock cycle, now I2 will be moved. The dummy instruction I2 will do write back, but because no signals are there with it, no control signals. When there is no control signal, no effect on anything, so nothing will happen because of I2, right? Then this is empty. Now at 6th clock cycle this will come here again, that is dummy, nothing will happen. Now who will come here? This I2 with proper signals. See, at 6th clock cycle really I2 getting executed, you remember that point. Okay, so far up to 6th clock cycle I2 is not executed. It's supposed to be executed at 4th clock cycle or something, but it did not happen. Now let's move I3. Since this time you want to be serious, then you seriously execute I3 as usual. When you move I3 here, then I4 will be fetched, because program counter will be incremented, because this time we did not disable program counter, so program counter will be incremented, so I4 will come. At 6th clock cycle I4, sorry, first this is wrong, actually we should not enclose this I3. Everyone is serious. Serious I4, serious I3, serious I2, dummy I2, dummy I2, because of 2 stall cycles. This is at 6th clock cycle. So at 6th clock cycle already I1, at 5th clock cycle end of the 5th clock cycle itself I1 got executed. Now at 6th clock cycle already I1 is out of the pipeline. Now see, at the end of the 6th clock cycle I2 will come out, right? I2 will come out. In that way it will be continued. Don't worry about the remaining story. So this is about the story. Understand? Now the same thing I will show in the boxes, because in the exam how to solve these problems quickly, how to understand the stall cycles quickly, I will tell you. Because sir, then why did you teach us these difficult things? This is actually the reality. This is all our imagination to solve the problems quickly. Then we will be we are not understanding all the details. In this previous thing we understood all the technicalities, right? But here we are not understanding. But in the GATE exam it will be good to remember this also. That's why understand the difficult things, understand the real details, and understand how to solve the problems in the GATE exam, right? Now see, at 1st clock cycle instruction will be fetched. Okay, now this is one more way of understanding the same thing. How to understand 2 stall cycles is a question. Now it will be easy for you, because already you had enough foundation. Now see, 1st clock cycle fetch 1, instruction number 1 will be fetched. 2nd clock cycle instruction 1 will be decoded, instruction 2 will be fetched. Now at the clock cycle 3, execution 1, decode 2, fetch 3. This is the place where you realize that instruction 2 got problem. Then you thought of introducing 2 stall cycles. That means you means your circuitry. Okay, so such a way automatic circuit we have to design, which works based on the instructions. Now that's why, because of that 3rd clock cycle, 4th clock cycle will be modified. So it's not like this. This is general idea, right? F1 D1 E1 M1 W1. F2 means 2nd instruction, 3 means 3rd instruction. This is normal thing, but now we are not doing normally. At 4th clock cycle what we do is we send 2nd instruction with dummy signals. That's why there is no effect of execution. That is what I said. So fourth clock cycle you understood. But remember one thing, at fourth clock cycle, did you decode D3? You supposed to decode D3, but what we did because of our circuitry, we decoded D2 only. Now everyone try to understand up to fourth clock cycle. Up to fourth clock cycle, if you see what happened is, first instruction is at memory, second clock instruction is at execution, but dummy execution. Third instruction is not at all in the picture because we cheated it and we are decoding the same instruction, which is second instruction. That is what at fourth clock cycle. Okay. Now, but see, third is fetched. Third instruction is fetched, but we are not using it, right? That's fine. Fetched F3, but decoded D2. So instruction 3 is not at all moved to next stage. Now come to fifth clock cycle. In the fifth clock cycle, normally first instruction is executed because you know this instruction is carrying dummy signals. This memory also will become dummy. Now this one. What about this one? Since you want to introduce two stall cycles, this decoding also will be done so that second instruction again will be made dummy by adding dummy signals. If you add dummy signals, and one more thing, can I change this to E2 because we are decoding instruction 2 and we are moving instruction 2 only, right? Now this is a correction because at that time initially we thought it's normal, but it's not normal. So third instruction is fetched at third clock cycle, but second instruction is decoded. Here the same instruction which is decoded is forwarded to next, which is execution, but dummy. Already same thing, whatever I taught already, that I am showing. Now you see, second instruction is made 2 times dummy, here and here, right? Now at the sixth clock cycle, at end of the fifth clock cycle itself, instruction 1 is done. Instruction 2 is acting like it is getting executed. Instruction 2 here also acting like getting executed. So there are 2 instructions on the pipeline, I2 and I2, which are both are dummy. Now in the next clock cycle, what we are going to do is, this time we will be serious, correct? So that we will be really fetching F3 again, but we are seriously decoding D2 and we are seriously executing E2. Understand? So that means what? Here we will be fetching F3, here we will be decoding again D2, right? Because we are introducing 2 clock cycles. You can understand like this. In this row we will be decoding D2. See, in this row we will be decoding D2, in this row we will be decoding D2. This time we will be seriously decoding. That means we are using the result of this decoding. Now, so here D2, then again after decoding, execution, memory in the later timings, write back, right, W2. Now let us focus. I am not writing the remaining things, but I would like to say one thing. Since this E2 is, this instruction 2 is doing, dummy execution, so that here also it will be dummy memory operation, dummy write back, because all the signals it is carrying is dummy signals. Similarly here, this will be dummy. So I can say that this decoding is unnecessary. That means it is not fruitful. That means not effective. This decoding also not effective, right? So, but on this F3 unnecessarily, but we can't do anything. This is one of the implementation. So you are fetching F3 so many times, but we are not using. Okay. Now in the next level, we will be seriously fetching F3 to use it. Now it will be like this. Next time again we fetch it F3, then we decode D3, then this time it will be F3 D3, it will be E3, it will be M3, it will be W3, in that way. So things will be carried away. I did not show what is I3 here. Assume that I3 is one of the instruction. Okay, so this is the way stalls will be introduced, right? Now focus. It is normal F1 D1 E1 M1 W1, but here because of the stall cycle F2 D2, but dummy E2, dummy M2, dummy W2. Again fetch third instruction, because by that time I don't know that we are going to have this kind of problems. That's why we fetched normally, but we decoded old instruction and we dumbily executed E2 M2 W2 here in this row. Now here again F3 will be fetched. but D2 will be decoded, but this time seriously it is executed, right? Now at 6th clock cycle, if you see, this is dummy execution, here dummy memory, but here serious execution of E2, right? Serious decoding of T3. Understand? So this is a way stall cycles are introduced. Now one more thing. You don't really require to write all this stuff. From now onwards, you remember. After this one, this is useless, however, right? This entire set is useless, right? But it happened. This entire operations are useless, but they are happened, right? They got happened. Sorry, this one. This entire thing is useless. This entire thing is useless. But this is useful, correct? So, though you are fetching F3, but you executed I2. Can I say that? So, from now onwards, I write like this for, shortcut. F1, D1, E1, M1, DEM1, W1. This is what the reality. But effectively, if you see, this is real execution of I2, right? Where it begins at 4th clock cycle. 1, 2, 3, 4, 5, 6, 7, 8, 9. From now onwards, in the GATE exam, whenever they say that there are two stall cycles, how to understand that is, see, F1, D1, E1, M1, W1. Second thing should start, second instruction should seriously start at 4th one. That means you can feel like this. That means if you write here F2, D2, E2, M2, W2, then that would be equivalent to this one, right? Now, F3 at 5th, F3, D3, M3, sorry, E3, M3, W3. Now, this is the way things will be executed. So, here there is a emptiness, right? This indicates that there are two stall cycles. So, this will be the final shortcut. But this is real implementation, right? So, this is about stall cycles.